Okay, so let's just kind of revert back, just so I have the recording there. So on problem number one, you base off this. We're looking at, this is basically telling us the slope. So we have a positive slope, a negative slope, and a positive slope. So we write that in there, having our turning points for our max and mins. For this one, they gave us the sine graph. When we have the two sines consecutive, it means we have a point of inflection that took place. So that's where our graph would have flattened out. Where we have a negative to a positive, that would have meant a minimum value. And then the third one, we only have one sign change that took place. It went from a positive to a negative, which meant right here in the middle, a max would have taken place. Okay? Feel comfortable there? I gave you number 4 as well to try, right? All right. So let's see if we could try number 4. Yes, we have Desmos that we could jump to, but let's see if we can try and play around with it without using Desmos. Okay, so first thing I'm going to do is I'm going to factor an x out, and that's going to leave me 2x squared plus 9x minus 5. So this is going to tell me that x is equal to 0 as one of our zeros. And then let's see if we can't factor this out. And we have the whole method. We could try guess and check. 2x and x. And we go positive 5 and negative 1. I believe that's right. Yep, that works. So that's going to tell me that x equals 1/2 and x is equal to negative 5. So basically, those values right there are where it is crossing the x-axis. Okay, so give the roots of this. These are all my roots. Okay, I don't have to find anything else from there. Okay, we good so far? All right. So how would we do problem number 5? What are they giving me as this? What is this? What does this look took place on this problem? I can't figure out the roots because of one certain thing. So this, yeah, this is a derivative. Okay? So derivative. Okay, so it's already the derivative. So then we have to think about, okay, give the intervals where it's increasing or decreasing. Okay, so let's think about just some values that could happen. If I took a value way, way, way to the left, like if I took negative 100, if I tried plugging in negative 100, I'm not going to try and even figure this out, but I know that would give me a positive times a negative times a negative, which would mean it would be positive. So way, way out here, our graph is above the axis somehow. Okay? So let's go the opposite end. Let's try 100 and see what would happen if I plugged 100 in. That would give me a negative value for this. It would give me a positive value for this, and give me a positive value for this, which comes out negative, which means over here, it'd be way down here. So if we wanted to figure out where this thing is increasing or decreasing, we have the derivative. What happens when I set the derivative equal to 0? It doesn't find me the roots. What does it find me? What is the derivative's main function? Anybody remember? So basically, this is what's going to take place in our scenario. Okay, so the derivative finds us the slope
of the place that you plug in at.
Mm-hmm. So this is just x equals 0. X equals 0. That means my slope is 0. So that's right here, I have a horizontal, just a horizontal line. So that could be a maximum or it could be a minimum value. We don't know.
Could it also be a point of inflection?
No. The reason it's not a point of inflection is, so what it shows you is basically that's raised to the first power, so that's going to indicate not a point of inflection. X minus 3 raised to the third, this is going to come out to this, which becomes this. This, because it's raised to an odd number that's higher than 1, this I think would give us a point of inflection.
Okay.
Okay, so at 3, we have some sort of point of inflection. And then at -4, that's going to give me something else over here. So -4 is where somehow my graph flattened out. So basically, without knowing too much, this graph probably does something like this, comes down, comes up, does something like this. So this came up, and then this like flattened out here, giving us a point of inflection. Oh, that's horrible representation. This is doing like something like this, and then going down. So that's basically what your graph would look like. So if you wanted to figure out your intervals where it's increasing or decreasing, so it's increasing from -4 all the way to that point of inflection, which is at 3. And then it's decreasing from -infinity to -4. And it's also decreasing from the point of inflection to infinity. Okay, that's a tougher concept. I get it, but I think it's doable. Let's have us on that page. Why don't I give you number 6 and number 7 for tomorrow? You can work on it. See if you can figure it out. It's a little tougher, but I think you might be able to kind of go with it. Note if it's f at x, you have the original function. If they give you f prime at x, they gave you the derivative. So see if you can figure those out. And then by the end of tomorrow, we should be able to have 6, 7, and 8 done. And if you're able to show me that on your workbook, I'll give you the points for it. Deal?
Yeah.